This next video is going to have a look at cracking, what cracking is and why it's useful. The first thing to understand is supply versus demand. So if you have a look here at the crude oil, all the different fractions, so I've chosen a few of them: gases, petrol, naphtha, diesel and bitumen. In general, we've got more bitumen than we do the gases. However, the demand for petrol and gases is much greater, and there's more demand than there is supply from crude oil. So we need to do something to get more of these gases, and what we do is we take the stuff that we've got an excess of, like bitumen and diesel, and we crack it. So cracking is where we take a large chained hydrocarbon, such as octane here, we apply heat and we use a catalyst such as aluminium oxide or porcelain chip. Now what this does is it breaks down a long chained hydrocarbon into a shorter chained alkane and alkene. So we end up breaking it here. The molecule then rearranges to give you an alkene, which in this case is ethene, and our long chain one. Now it's just a case of this being broken down, so if we've got 2 of our 8 carbons here, we're left with 6. And it's an alkane, so we have no double bonds, we just fill it in with hydrogens. So that's C6H14, which is hexane. So again, that definition is the breaking down of a long chained hydrocarbon into a shorter chained alkane and alkene using a catalyst and heat. And a catalyst is something that's used to speed up the rate of reaction. That's all you need to know for this exam. So in the exam, you might well be asked to draw and explain the cracking process that you've done in the lab. Nice and simply, what that is you have a Bunsen burner and you heat a boiling tube. In that boiling tube you've got paraffin, which is your long chained hydrocarbon, which has been soaked in mineral wool. So you push the mineral wool to the end, you put the catalyst, which in this case is the porcelain chip, in, and then you heat. You start heating both of these back and forth, and eventually you'll see some smoke being produced. This smoke will come through the delivery tube, down into here, and then up through here. So in here you will collect your alkane and your alkene. This will displace the water, which was in here, which was full at the beginning, and then you'll be able to test to prove that you've got an alkene by adding bromine water. If you remember back to the alkane and alkene section, you add bromine water, and that will turn colourless in the presence of an alkene in here. So get used to writing down the method and get used to drawing this apparatus, because it may well come up and it could well be a 6-mark question.